Okay, so check this out. I made a solar heater outside my garage to help heat it. You know, the ones that have the aluminum cans, you paint them black. It actually works really good, but the problem I seen was, you know, you have these two big holes through the walls of your garage, and the sun goes down and it gets cold, and then you got a draft. So I wanted to figure out a way to open and close those holes, you know, like when the sun gets hot enough to make heat, and then turn the fan on to circulate the air. So what I did actually, I made this device, and it's got this linear actuator on it that I figured out the geometry and made the doors open and close on each side. But what's really cool about this is there's a thermostat inside the top chamber of the solar heater outside. So when it gets above 15, 16 degrees Celsius outside, it closes and it enables this enable relay, and that turns the system on. So what it does then, power goes across, and it actually turns on the this relay that turns the fan on. So the fan is actually 120 volts because it draws a lot of current, and I didn't really want to waste batteries pulling down with the fan. You know, a 12 volt fan is going to be about 15 amps. That's going to kill your batteries fast. And this is just a supplement heat, so you know, I wanted to control the fan on and off and just use 120 volts. And then what it does is it also powers this H-bridge, which I created with these two relays. And the H-bridge changes the direction of the linear actuator. So basically, once it's warm enough outside and it starts making heat, the H-bridge actuator opens the doors, turns the fan on, and it actually starts circulating the air from the bottom of the floor and then out the top. And when it gets cold outside, or the sun goes behind the clouds, and there's not enough heat in the chamber, that thermostat, it'll actually open. And then what happens is the normally closed circuit powers, and it actually closes the closed H-bridge circuit, and the door is shut, the fan turns off, and it sits there waiting for heat again. The linear actuator is controlled by these two limit switches, and they simply cut off the power to the coils on the H-bridge relays. So if it's open, you know, when it gets to the end of the stroke, it actually doesn't sit there and try to burn the motor out. Everything's controlled by some fuses, and I've got a few other things to do. I've got a manual switch, which basically just simulates the thermostat. So if the thermostat closes, fan turns on, and the door is open. And now we have access to the upper chamber of the heater that's outside. And the bottom is open to actually draw the colder air from the lower floor. Now the other thing I made was this chamber here, which connects the bottom to the top, so I can actually turn on the fan and circulate the air within the garage, even if there's not heat outside. And I've got decks here for more batteries. I've got another project that I'm going to add to this later, but this is the basics. So it's pretty cool. But there's no heat. The door is closed, the fan turns off, and then once it's hot enough outside, the door is open, the fan turns on.